Okay, so we have 3 points on this graph, and we want theta to be a quadratic function of t. We're going to test that. After we get our function, we're going to see some of the other points make sense. But so we're going to write theta equals a t squared plus bt plus c. A t squared plus bt plus c is standard notation for a general quadratic function, where a, b, and c are numbers that we don't know yet. But we're going to find them from these 3 points. How do we do that? Well, we have a value for t and a value for theta corresponding to this point. If this point fits this function, then we're going to say, well, okay, let's see. Theta is 21 pi when t equals 60. And of course we know these things have units, but it's going to be a little cumbersome to write down the units. We'll put units on this when we're done. Okay, so again, theta is 21 pi when t is 60. So we could write, okay, if the quadratic function fits these first 3 points, then 21 pi has to be a times 60 squared plus b times 60 plus c. And for this point, if the quadratic function actually goes through this point, then we know theta is 35 pi when t is 88. So we get pi equals a times 88 squared plus b times 88 plus c. And then 47 pi equals a times 150 squared plus b times 150 plus c. Okay. Well, I can rewrite these equations. Now, what I have now is I have 3 equations, and each equation has 3 unknowns, a, b, and c. Well, we know about simultaneous linear equations, and we know we can solve them. If we have 3 equations and 3 unknowns, then we expect to be able to solve them. Now, sometimes you have degenerate systems and so forth, so sometimes it doesn't work out, but in this case it is going to work out, okay? But we're pretty much guaranteed of that. We have 3 points with distinct x coordinates and distinct y coordinates. We know we can fit a quadratic function to those 3 points. If we don't know that, well, we just found out. Okay, at least if you believe me, you just found out, right? Always be skeptical. Okay, so I'm going to fudge a little bit just to make the numbers a little easier. Okay, I'll explain this in a second. It's been a strange day. Don't have all my concentration, so I wanted to write that down before I started talking, just to make sure I wrote it down correctly. Okay, now I fudged a little bit. Instead of 21 pi, I've just got 20. Okay? Now we're going to understand that pi goes through this, and when you do this, you keep the pi in there. But I'm just going to write these equations down, or equations close to these equations, so making the numbers easy to follow, and also, you know, making sure that I don't screw up, at least reducing the possibility that I screw up. Okay, so let's say we've got 20 equals this. Very similar to this equation, but not quite the same. And then 35 equals, now I'm going to pretend instead of 88, that's really 90, just because it's nice and round, especially on this coefficient of a. But if you do it, you know, use an honest estimate and use the actual numbers. Don't fudge like I'm doing. I'm doing this to illustrate, not to get a totally accurate result. Not that I'm going to get one because of a hand sketch graph and not being all that careful with it. Okay, and then we're going to have 47 equals 22,500 A plus 150 B plus C. Again, the 3,600, 8,100, 22,500 just come from squaring 60 and 90 instead of 88, and then 150. Okay? Now I might make an arithmetic mistake here, so keep an eye on it. I'll try to be somewhat careful. Okay, so now we have three equations. I'm going to label this equation number 1, this equation number 2, this equation number 3. Then, and I'm going to put a little circle around it to indicate the number of the circle around it refers to the equation. So I'm going to eliminate one variable at a time. I'm going to solve these by the method of elimination, which you should be familiar with. But if you aren't, then you're going to have to pick it up here. And if you are, well, you can just kind of skip ahead. So I'm going to do the third equation minus the first. So I have 47 here, 20 here. 47 minus 20 is 27. 22,500 minus 3,600 is what? Well, 22,500 minus 4,000 is 18,500. 600 more is 19,100. Now there's where I might have made a mistake. I'm not even going to check myself. You can check me. 150 minus 60 is 90. And C minus C is 0. So we've eliminated C from these two equations. And now I'm going to do equation 3 minus equation 2. Okay? So 47 minus 35 is 12. 22,500 minus 8,000, 14,500, but we have 100 more, so it's 14,600 A plus 60B. Now that's progress. We had three equations and three unknowns here. If these equations are true, then these equations have to be true. In other words, if my values of A and B and C satisfy these three equations, then my values of A and B have to satisfy these two equations. Okay. Well, now, I'm going to eliminate B. Numbers in front of B are smaller than numbers in front of A. Okay, so there's a little more room here. So let's call this equation blue 1 and blue 2. So what I'm going to do, and this should be familiar to you, I'm going to multiply blue 1 by and I'm going to multiply blue 2 by negative 9. And why is that? It's because if I multiply 90 by 6 and 60 by 9, I get 540 both ways. So if I multiply this one by 6, I'm going to get 540b. If I multiply this equation by negative 9, I'm going to get negative 540b. So that when I add the two, b is going to go away, and I'm going to end up just with an equation in A. Okay? Now again, watch my arithmetic. 6 times 27 is 162, I'll bet you. Now 6 times 19 is 114. It'll be 114,600. I'm not going to explain that, but it's good if you can do mental arithmetic so you don't have to keep punching buttons on a calculator. Of course, you always want to check yourself on the calculator. And if you don't agree, then either your arithmetic or the calculator is wrong, or you did something wrong with the calculator. Anyhow, okay, now 9 times 12 is 108. And again, watch me, I'm doing this and I'm not double checking it. And 10 times 14,600 is 146,000. If you subtract 14,000 from 146,000, you get 131,400. And that'll be negative because you multiply by -9. And then you're going to get minus 540b. Again, check my numbers. I don't guarantee them. Just showing you the process, but I'm actually trying to get the numbers right, so you can see if I do make a mistake, which is not unlikely, then I'm not infallible, not that you probably think I am anyway. Okay, so we get 54 equals what? Well, it's negative 131,000 plus 114,000, okay? That's going to be on the surface of it, negative 17,000. But it's actually going to be negative 16,800. Is that right? Yeah, I think that's right. And if it's not, just correct it. And now I can solve for A. It's going to be 54 over negative 16,800. Well, I'm not going to attempt to do that, except to note that 300 times 50 is 15,000, and 300 times 54 is going to be 16,200. And what did I just say? Didn't get enough sleep last night. So I'm thinking this is pretty close to 0.003. Okay? It's 3 times that. I'll give you like 50,000 and yeah. So A pretty close to negative 0.003. Well, that's only one significant figure. The other significant figure I can tell is probably pretty small, like negative, I could actually probably figure it out. What am I doing? Okay, 3 times 54 is 162, then you have 600. Yeah, it's going to be negative 0.0031, probably 3 or 4 after that. And again, go ahead and use your calculator if you want to see if I did that reasonably well, but that's about it. Okay, so there's our approximate value of A. Now, I can take that value of A and plug it into either of these two equations, just either one, well, either of these two equations, we don't want to do these, either one of these two, and solve for B. So if I plug in negative 0.0031 for A, I get a number here, subtract it from both sides, divide by 60, and I've got B. Then I can feed the values of A and B back into any one of the 3 original equations and find the value of C. Now that again should be a familiar process, but I've gone through it in detail just in case it isn't. Okay. Now I'm not gonna do it. I'm not gonna make you watch me figure this out any further. But off camera, I'm going to go ahead and figure out what I think maybe the values of B and C are, and see if we've got a good model.